Hey everyone, hope you're all doing well. You'll recognize this Shopvac from previous videos. It used to be attached to a paint bucket. The idea was to increase the capacity of the Shopvac and catch more debris, but that concept worked well, but the filter still clogged up on the inside, so I thought I need to improve that. And to try and increase the efficiency of the Shopvac, I looked at the internet for a couple of ideas, and I found this on Printables. It's a Cyclone or a dust separator, or some people call it a dust deputy. It's designed for a 2-inch hose or a 65mm hose. It's a 2-part print system. It's printed out of PLA. I applied a bit of silicone in between the two joints just to make it airtight. I then attached it onto a 25-litre bucket and cut a hole in the lid of the bucket. Also mounted that onto the lid and sealed it off with silicone. I then built a quick and simple car to keep the bucket and the separator as well as the Shopvac all together. It's on wheels, so it's mobile. We can move it around the shop. So let's try and test the efficiency. So as you can see, the bucket is clear and empty. The filter is a bit dirty and it needs replacement, but it still works fine for this application. So let's go ahead and test it. We'll suck some dust from the bucket and see how it goes into the separator, into the bucket below. Okay, so let's see how much dust is left in the Shopvac. As you can see, the Shopvac bucket is completely empty and the dust filter is fairly clean. Let's have a look at the Cyclone bucket. Okay, as you saw, the Cyclone is quite efficient. It moves all the dust from the Shopvac right straight into the bucket. But let's take it one step further. I'm going to build an auto switch to switch the Shopvac on and off automatically as soon as I power on a power tool. And in order to do that, we need to create some sort of a smart switch. We're going to use an Arduino, a current sensor, and a relay. This is not my design. I looked on the internet for a couple of ideas and I found Zach from Bite Size Engineering. He built the exact same switch for his workshop on the same principle. So what we have is the Arduino, the current sensor, and the relay, all powered by the 5V DC. I'm just using an old cell phone charger on the USB cable. This is connected onto a normal power socket. I changed the design so I can make use of a standard South African double plug or a double wall outlet. Connected it onto the electronic devices. So I'll put a graphic up on the screen to show the connection between the Arduino, the current sensor, and the relay. Essentially what it does is the Arduino is programmed with a circuit switch or a sketch to turn the relay on and off once current is detected through the current sensor. So the electrical connections will be as such. We've got the 220-volt supply coming in from the wall, connecting onto the live terminal, the earth connection onto the earth terminal, and like I mentioned on the neutral terminals, I had to split this for one for each socket. So we've got the neutral coming in from the wall socket, connecting onto the current sensor. The current sensor is then bridged onto the common port of the relay. The relay is then connected from normal open onto the first neutral connection, and the current sensor is then connected with the neutral onto the second neutral connection. So let's go ahead and power it up and give it a test. So that's the 5V power supply. Alright, let's go ahead and test. The smart switch is powered with the 5V DC. The Shopvac is plugged into the vac port, and the tool, my sander in this case, is connected to the tool port. So what will happen is, as soon as I turn the sander on, the Shopvac will turn on. If I turn the sander off, the Shopvac will stay on for 5 seconds and then turn itself off. There we have it, smart switch. The sketch file for the Arduino as well as the print file for the enclosure is available on Zach's website, Bite Size Engineering. I'll pin it down below. Thanks for watching.